All right, let's look at the homework 7.6, problem number 6. All right, so we want to find the minimum distance from the surface, which is the cone, from the given point 8, 0, 0. All right, and so we want to minimize the distance. So this is a squared version of the distance formula. All right, so let's minimize that. All right, so in this case, we're going to have to, maybe it's probably better to rewrite this constraint. So this is a constraint. I'm going to actually square both sides. So you have z squared is equal to x squared plus y squared. The reason why I wanted to do that is that I do not want to deal with the square root, so I try to get rid of it. All right, then I can just put all the all the terms on the left-hand side. So we get the z squared minus x squared minus y squared is equal to 0. All right, so that way this is going to be our g. All right, so capital F is going to be, right, so you have a quantity x minus 8 squared plus y squared plus z squared minus lambda times quantity z squared minus x squared minus y squared. Right? So let's take the partial with respect to x. Right, so this is going to give us 2 times quantity x minus 8. Partial of that is 0. Partial of z squared is 0. Then you have, let's see, negative lambda. It's just a constant multiple. Right, partial of that would be negative 2x. So it's going to be positive 2x. Right, so we get set that equal to 0. Right, then partial with respect to y would be 2y minus lambda, and partial of that would be negative 2y, and set that equal to 0. And partial of z, well, partial with respect to z would be 2z minus lambda, and partial of that is 2z. Set that equal to 0. All right, and you can see that this is going to be, let's see, I'm going to factor out the 2y. So it's a 2y. Then you have a 1 plus lambda is equal to 0. So there are a couple cases. We could have y equals 0, or lambda equals negative 1, so that we can make this guy equal to 0. From this here, let's see, we can do the same thing, 2z and 1 minus lambda in this case. So this is going to be either z equals 0 or lambda is equaling 1. All right. And the first equation, let's see, how do we rewrite that? So maybe first I'm going to divide through by 2. All right, so you have x minus 8 plus lambda x is equal to 0. All right, and I'm going to collect these two terms. So it's going to give you 1 plus lambda x, and I also want to put this guy over to the other side by adding 8 to both sides. So this is going to be equal to 8. All right. Then one thing we can do is here. All right. So since you know, this product has to be equal to 8. So lambda can't be negative 1, right? Because if it's -1, then the whole thing would be 0. So, but we have to get 8. So we know that lambda cannot be -1, so you can eliminate this possibility, right? Which means that y has to be 0, right? And also, x cannot be 0, right? So I've got to do the last one. F lambda is going to be simply negative z squared minus x squared minus y squared equal to 0, right? So in this equation, maybe I'll get rid of the negative sign, and we have z squared, and maybe this equation might look a little bit easier, x squared plus y squared, right? And we already know that y is 0, so this is 0, right? And also here, from this equation, x cannot be 0, because if x were 0, then this product would be 0, but we have to get 8, right? So x is not 0. So if x is not 0, z is not 0. So we know that we can eliminate this possibility. So we know that the lambda has to be actually equal to 1, all right? Then we can just plug this 1 in here to get the equation. So this is going to give you 1 plus 1 is 2, so 2x equals 8, and divide through by 2 to get x equals 4, right? Then we can plug in 4 into this equation, and then you have z squared is equal to 4 squared plus, of course, 0. So we know that the z is going to be equal to 4. I mean, it's a plus minus 4, but we're looking at the cone where it's a top half of the cone, so it's going to be positive. All right, so we know all the values. So we know that the x has to be 4, and the y has to be 0, and z has to be 4. Right? So the distance d is going to be, right? Don't forget the square root, right? Right. So you have 4 minus 8 squared, that's 16, plus y 0, so it's a 0. Z is 4, so it's 16. So it's a square root of 32, which is equal to, all right, let's see, it's 4 times 4 is 16, and then over 2, all right, then and 2, all right. So 4 square root of 2 is the minimum distance, all right. So let's type it in, 4 square root of 2, all right. Let's check the answer. All right, I came back and it looks like we got this one correctly. All right, that's it. I hope that this was clear.